All right, y'all, we are looking right now at the first section of the topic 8 notes where we are talking about transformations. Transformations are something that you've talked about probably back in elementary school math. A transformation is when you do something to a shape that changes something about it, changes its orientation, changes its reflection, changes its location. There's a bunch of different things we can do. What we're looking at today is just the first page where we talk about translations. A translation is the fancy word for a slide. Okay, so you would take a point or a shape or whatever it is and move it to a different location. Okay, so the difference between what you did back in elementary school and what is going on in our stuff here is that we're going more in depth by giving all of our objects a specific location on an XY plane. Okay, so a translation is a slide. The first thing you need to that's the first blank that needs to be filled in on the notes packet. And the way you can remember that and not get it mixed up with any of the other transformations is that slide starts with SL, and you've got that same SL right here in the middle of translation. So a translation is a slide. I'll try and emphasize that as we move along. So the next thing I want to point out here is the notation that we have surrounding translations. The notation is this thing right here. Okay, the little T that stands for translation, and then you've got two numbers inside of some funny little brackets. Okay, the the T, of course, stands for translation, but then these two numbers tell us in what direction and how far we're going to move or we're going to slide whatever the object on the graph is. So when we start off right here, we start off with our original image. Has 3 points. It's triangle, and the three corners are located at A, B, and C. These given points right here. And what we need to do is look at our number that's given to us. The number that's given to us first is 8. This number has to do with our x values. Okay, this is just like if you were putting a point onto the graph. The x values come first. This second number has to do with your y values. Now, when you're putting points on a graph, you guys already know that when you have your coordinates, the x value is first and the y value is second. So that lines up with just like it is. But what you need to think about here is that when you're talking about an x value, you're talking about if you started at the origin, how far to the left or how far to the right did you move to find the location of this point? It's the same thing for the y values. The y values, how far up or how far down did you move from the origin to find where that point is? So for our original A, we were at -9 and +6. So that's where our point was, -9, 9 units to the left of the origin and 6 units above the origin. When we look at these two numbers right over here, this right here has to do with your right and left movement, your horizontal, your lateral movement. And this number up here, the second number, has to do with your up and down movement. So we're talking about how this is translations. Okay, we're taking this triangle. What we're going to do is take this triangle and slide it somewhere else. We're going to slide it 8 units in the x direction and 8 units in the y direction. So if we're going positive 8 units in the x direction, positive 8 would be moving 8 units to the right. And so what we would do is we would take the x value and we would take whatever it was and add 8. Similarly, if we're going -8 units in the y direction, that means we're going to take all of our y values and subtract 8. All right? So if we're adding 8 and subtracting 8 from our x values and y values, that's going to move us to -1, -2. Okay? That -9 plus 8 is -1. 6 minus 8 is -2. Our new b coordinate, after we add these numbers and after we slide it over in this direction that's given to us, is going to be at 6, -6. Our new c will be 1, -6. Now, the difference between these points that we started with and these ones that we moved to, the difference in the notation is this little thing right here, this little apostrophe that's attached to it, okay? When you say that out loud, you would say A prime, B prime, and C prime. That's something that comes up in some later higher level math and science classes also. Okay, so when you have the apostrophe attached like that, that's A prime and B prime and C prime. That's what that apostrophe is, and that tells us that something has been changed from the original A to the new A. Okay, so I'm going to go ahead and plot those points, and we'll see what this looks like. We've got -1, -2. We've got 6 and -6. And we've got 1, -6. And this right here, what I'm about to put, this is your new translated triangle. Something I want you to notice is that the shape of this triangle did not change when we moved from here to here. The only thing that changed was the location of the corners. Okay, that's what a translation is. This triangle is still the same size. It's still facing the same direction, has the same orientation, but it moved from up here to down over here. Up next on your paper, we've got another triangle and another translation from a translation in the direction of -6 and 2. All right, so what that means is that we're going to take all of our x values and we'll be subtracting 6. We'll take all of our y values and we're adding 2. All right, so if it's a minus sign, we're subtracting. If it's a positive number, then we're adding. And that makes sense because positive numbers would be going up the y-axis. Negative numbers would be moving to the left, okay? So if we're subtracting 6 and adding 2, that's going to turn it into -4, 4. We're subtracting 6 and adding 2, -6 and +2 will give us 1, 8. And then -6 and +2 again will give us 3, 4. All right, so I'm going to plot all three of those points just here real quick. -4, 4, and 1, 8, and our last one at 3, 4. And again, you can see that our new triangle hasn't changed shape. The only thing is that these points, D prime, E prime, and F prime, are in a different location than the originals were. Okay, we took this whole shape and we just slid it up to where this one is. All right, so it's pretty simple. In my opinion, this is far from the most complicated thing we've ever done in geometry. And so it's pretty simple. You just use that notation. You use these numbers that are given to you to find where your new points, your new shape would be located. What I want to do now is go on to this right here, and this right here has this graph has 6 versions of the exact same rectangle, and what it's asking us to do is fill in these blanks with how would you describe this translation? Okay, so it gives us one example already done for us. The example it's already done for us is translating from 1 to 2. So that's translating from right here, these points, over to these points over here. Something to notice right here, okay? It tells us that the two numbers are 13 and 0 in this translation. What that means is that if we start right here and we moved this point, the top left corner of number 1, all the way over to the top left corner of number 2, that moved over 13 units in the x direction. Okay, that moved over 13. You can count them out right there on your paper, 13 units. The same thing happened if we connected this bottom right corner to this bottom right corner. It'd be 13 units over. Okay, that's where this positive 13 comes from. The next thing we see is a 0. Now, the question, why would there be a 0 as your second number? And the answer is this. When we slide from 1 to 2, there was no vertical movement. there was no change in any of these y values. This y value and this y value are still the same for those 2 points. Okay, so there was no change, so that has to be a 0 right there. All right, what I want to look at next is this problem translating from 5 to 4. Okay, when we translate from 5 to 4, there are a couple ways you can do this. One way is like this. Okay, I'm going to look at the top left corner again. On the top left corner right here, I can see that the x value is 2. On the top left corner of number 4 over here, I can see that the x value is negative 8. Now, if I'm a good math student and I can keep track of this, I can just say in my head, well, the difference between positive 2 and negative 8 is 10. So that must have been a translation of 10 units to the left. Well, okay, that's perfectly okay. That's reasonable. You can do that by just finding the difference between the x values right here and right here. But that is going to be a difficult process as soon as you start adding and subtracting negative numbers, okay? Y'all, I've studied math for a lot of years, and to this day, I still mix up positive and negative signs when I'm adding and subtracting with negative numbers. So it's going to be easiest for you to just go from one corner, like take the top left corner right here and just count over as much as you need. And just count that we move 10 spaces to the left and we move 2 spaces down to get from the same corner of number 5 to the same corner of number 4. Okay? Just count it out. Okay? We move 10 spaces to the left. And y'all remember that smaller numbers are on this side of the x-axis, larger numbers on this side. So we're moving in the negative direction. So we have negative 10 as our first number. And then we move down. So we've got negative 2 as our second number. Same process when we go from 2 to 3. Count over how far it is from this corner over to here, and then count how far down you went from here to here. Okay, we do the change in x values first, the change in y values second, and when you count it out, you moved 11 to the left and 5 down. So we've got negative 11 and negative 5. Okay, going from 5 to 6, this time we did not move to the left. Going from 5 to 6, we moved to the right. So that first number shouldn't be negative. That first number should be positive. And that's exactly what we have. We moved over 1, 2, 3 units to be in line with that one. So a positive 3 is our first number. And then we moved down 6 to get from here to in line with this corner. So we moved over 3 and down 6 to translate from position 5 to position 6. This next one is interesting. When we go 6 to 2, look at what's happening. We go 6 to 2. That is a slide of this rectangle straight up to this rectangle. Okay? There is no change in any of your x values. There's 0 for your first one. There was no left and right movement, so there's nothing to write right there. That 0 is nothing. But we did move up a whole bunch. So our second number should be positive, and we moved up by 13 units. Our last one, 3 to 4, is just more of the same. We moved to the left by 2, we moved down by 4, so we got negative 2 and negative 4. Okay, this is all we have for the first section of notes. It's pretty simple stuff, and I encourage you to not get too bogged down in the fine details of those negative numbers. All right, just count it out if you're really getting stuck, and we'll get back at it another day with the second section.